about modeling and talking a little bit about incorporating other tools outside of the standard modeling tools inside of Maya. Now, I know I haven't really touched very deeply inside of Maya in terms of modeling techniques, but I think it's really important that I start introducing you guys early to other sort of modeling tools. 1v1v me on something for the people. You want me to 1v1 you, Owen, on something for the people? Yeah, I don't follow. Maya's still refusing to download. Okay. Wow. All right. So that's posing some potential issues. Error 1603. Did you have a Google? Find out what error 1603 is? Let's have a look. 1603. Looks like just an admin privileges thing, right? So when you go to install, instead of installing by double clicking, what you might need to do is right click on it and install as admin, right? So if you come over, you right click on something, you'll get a drop down and install that as administrator. Windows security has just wreaked havoc with a lot of people in the last couple of years. Maya's not working for me. Okay. One of the things that's I want you guys to know as well in terms of feeding back on software and how software operates, from now on, I want you guys to be specific, right? When it comes to software diagnostics, it's kind of like medical diagnostics. Doctors need to know all of your symptoms before they can figure out what's wrong with you. Same with technology, right? Like, it's better, instead of saying Maya's not working, say something like, well, when I launch Maya, this happens. I get like a little command window and then it disappears and everything's gone, right? So that gives me more information to go on, and I'll be able to help you a little bit better if I know exactly what it is. See, I can't see what you're seeing when you go to launch Maya or go to launch an installation, so I need a little bit of help. My laptop is extremely laggy, so it may take a while for Maya to open. Yeah, that's no problem. Downloads to 53%, then fails. Okay. So sometimes, occasionally, if you take, it leaves sort of vestiges of what it downloaded behind, right? So sometimes if you take that download in progress or that file that sometimes has that suffix .cr download, if you delete that and then try again, sometimes it resets something in the background. Windows may be, I don't know, indexing the file or something like that. But I find if you delete it, it blows whatever Windows is holding on to in terms of data in the background, and you can download it again, and you might have a bit more success that way. Sometimes as well, if your sort of download speed kind of throttles down to almost zero, it breaks the download, so the files are broken. So, you know, that could be something as well. Something I recommend you guys do is to download a speed tester, right? You guys might need this, or you might find it, some of you are probably already using this, but it's super handy in this day and age when everybody's online, right? So this one's free, and I've been using it for years. It's from Ookla. If you write speed test, you'll just get it. Speed test by Ookla. Now you can run it directly from the web page. You don't have to download it, but you get more of an accurate reading if you run it off your PC, right? And then so with that, I can just come in here, just hit go, and it'll give you the ping. So the ping is like a ping is a signal that's sent out and comes back, right? So it literally pings off something and comes back, and it gives you a reading of the speed of that, just to give you an idea of how fast things are going out and coming back. And then right now it's testing my download speed. So, wow, it's pretty low today. Averaging about 15.81 megabits per second. Usually my usual connection is hovering around 30, right? and then it'll give you an upload speed. Yeah, if you're doing a speed test right now, right, you'll be able to see. So I'm averaging about 7-8 megabits per second upload speed. So that's what I'm currently clocking right now. So this will give you an idea of how good your signal is. And then you'll find that at nighttime, your speeds will be up. There'll be a lot more, right? So you might want to save your downloads for the evenings if that's the case, right? Yeah, okay. Yeah, that's not bad. You're clocking some good times there. So, Owen, you got some good times there in terms of download and upload, right? So that should help you guys out. What I might do then, considering some of you guys are still struggling with Maya licenses, I'm going to let you guys get that sorted out. I'll talk about theory stuff, right? But there's only so much I can talk about theory stuff before you guys have to get in there and start getting your hands dirty, right? So I'm going to talk a little bit about let's come in here and create I don't know, just a polygon primitive cube for a sec. I'm going to hit the F key to frame up on it. And the fact that the cube came in really, really tiny tells me that I need to come over here and set my scale, right? So I'm going to come over to my Windows, Settings, Preferences. Make sure that I'm set to the proper centimeter scale. Yeah, and then I'm going to come in and I'm going to set my grid. So display grid. Make sure my grid is reasonable. I'm going to set my grid to actually 500 by 500 units. And because I've set it to centimeters, oops, these are 500 centimeters by 500 centimeters. And grid lines every 100 centimeters. Let's just apply that, right? So it's a nice, tight, small grid, right? My default objects are still coming in really, really tiny. So let's talk about this idea. So are we using Maya today? My sister hates me because I took the laptop off her, but if we don't need to use it today, I can give it back to her. Yeah, there's a lot of people who are, there are a lot of people who are currently sort of trying to download and install Maya at the moment. So I'm not going to dive into a Maya specific tutorial today. I'll talk a little bit about theory. So if you are arguing with your sister, you can hand over the laptop. I'll just be doing theory-based stuff today. Al, do I stream? Yes, I do. So I'm streaming right now. Now I've got a easy lecture today, not bad. Yeah, well, we'll see. We'll see how easy it is. I was missing some of the supporting files from Maya. Okay. Yeah, so I'm on Twitch under Alkang Art. You should be able to find me. And I stream all of my lectures, right? So you'll be able to catch up. Now, Twitch only holds onto it for 8 days or something like that. But I'm using Restream.io. So it's actually going to a YouTube channel as well. So if you do, actually, I'll just stick the links in here for you. Super quick. Let's go to my channel. Oh, there's that one. And let's go into YouTube. This one's going to, let's go into my other account. Oh, come on. There you go. Okay. There you go. Okay, cool. Yep. Yeah, so the streams are being kind of captured and cataloged there. Okay, so I also send my streams to the YouTube channel here. Oops. Let's kill that. There you go. Right, so you'll be able to, the YouTube channel, I believe, is my permanent repository, right? So it holds on to all of that there. So you'll be able to go back through the history and just check it out, right? And it also goes to my Twitch and a few other places. But there we go. Okay. So I want to talk a little bit about sort of the elements that kind of come into play when you are modeling a character, right? One of the big things that I don't like about a lot of the tutorials that I see out there is that they generally teach modeling kind of in isolation. Oh, I'm not streaming on Discord. No. Oh, right. Actually, I am not streaming on Discord. Right. So let's pop that screen up. Sorry, guys. Maybe I haven't had enough coffee today. There we go. How's that? So, streaming on Discord and on Twitch. And hoping my bandwidth doesn't throttle and choke out. Okay, so one of the things that I don't like about a lot of tutorials that are out there is that they stick primarily in modeling. It's a very linear kind of approach. Model, then UV, then texture, then light, then render, right? So I'd like to kind of introduce a number of different elements at the same time, very slowly, right? I'm gonna minimize the UV toolkit. I've been using a third-party UV unwrapping tool for a number of years now, so I don't really use UV toolkit, but this brings up an opportunity about talking about other pieces of software that you might want to incorporate in your workflow, but we'll kind of get to that, right? So here I've got an object, and again, it's got the default material on it. Now I'm going to switch over to my attribute editor, because remember the attribute editor over here is generally what modelers use, and really you only just use this window primarily most of the time to get where your object is located in 3D space. This is the transform window, or the transform node, right? And so there's our 3D object, and I'm going to come in here and straight away I'm going to create a camera, right? The reason why is when it comes to the fine art of rendering, a lot of people occasionally think that the renderer or rendering is its own separate kind of thing. It's its own separate stage in the pipeline, when it's actually not. A renderer is completely tied to a material library, textures, cameras, specific lights, and render. They all kind of work together. So to separate those is kind of puts you in sort of an awkward position if rendering artifacts start to show up or rendering errors start to show up. Whereas if I can show you the connection between all the elements from a fairly early stage, you'll be able to understand that when your render craps out, or if your render takes like 15 minutes a frame, you can at least have a sense of why that is going on. Everything is feeding the renderer anyway. All your geometry data, everything, right? So I'm looking at my camera here. I brought one in, right? And I can place this anywhere. Now, the reason why I bring in the camera is because we don't want to use any of the cameras that already exist in our scene, right? So let me come up over to Windows and Outliner so I can show you what I'm talking about. So these are the cameras that we currently have. I'm currently using the perspective camera to navigate around my scene. Now, one of the things that I consistently find people do is that they will use and they will animate their perspective camera. Of course, they're looking through it, they're moving around inside of it, and they'll set keyframes on it, and you never do that. What you want to do is bring in a separate camera. So you can see I've got my geometry on my camera, and very similarly to the way I talked about packaging up a character, we need to do the same thing here, right? So I'll hit Control G to group my geometry, and I'll call that geo, just like I did with the character. And I'll come in here, select my camera, Control G that, and I can call it whatever I want. Usually I call it shots, because I'll have more than one camera that I generally tend to work with, right? So we got our shot camera in there. Now I'm gonna hover my cursor over the perspective view and tap the spacebar, and we go back, it'll blow up that view. So if I tap the spacebar, we can go back and forth from a 4-panel view to a 1-panel view. And I'm going to position this camera, right? So to do that, I want to look through it, right? So here's how you look through the camera. If we look at all of these menus here, and again, remember, these menus in this box here deal with what you see through the viewport, real-time rendered, right? We got our shading, our lighting, et cetera, et cetera. We got this one called panels. So the panels, we can do quite a few different things. What I'm gonna do straight off the bat is I'm gonna pop into my perspective view. And you can see I've got my perspective camera and camera 1, which I just created, right? In fact, let's pop over here so we know exactly what we're doing. I will call this shot 1. So that'll be my shot 1 camera. So when I go to my panels here and go to perspective, there's my shot 1 camera. Boom, now I'm looking through it. Now I'm actually moving the shot 1 camera, right? And it's got all the same functionality as the other kind of viewport, the perspective viewport, exact same navigation and everything, right? Now, I want to take this and separate it from my perspective view, and I'll show you why. So to do this, you know, being inside my camera, how can I tell I'm inside my camera? Down here at the bottom of the viewport, it says shot 1. So now I know I'm definitely looking through my camera. There's a few other things that I'm going to set that'll help me with that. In fact, let's set that up now before I tear this apart. So notice how when I go to my shot 1 camera, but I go to my perspective view, they kind of look the same, right? If you look down here, you can see it's perspective, but they sort of look the same. If I flip over in my perspective, my shot camera, it looks the same. It's very, very easy to forget which camera you're in at any given point. So what I generally tend to do inside my shot cameras is I'll come up to here. All these icons, again, deal with what you see directly through your viewport, right? What I'm gonna do is I'm going to come in here and I'm gonna turn on my resolution gate, right? So this grays this out here, gives me a nice mask and shows me the resolution of my image, right? So if I pop back into my perspective camera doesn't have that, right? So right away, I've got a visual signifier to say, yeah, you're in your shot camera, right? So that's really, really cool. I also turn on safe action. Where are we here? That's the film gate, the gate mask. There we go. Safe action and safe title, right? So the safe action and the safe title. I think I told you guys this before, but the safe action says that any action inside this rectangle will be caught by your audience. They won't miss anything, right? And this has to do with the way old television screens used to work, right? So if you had an old television screen that was like, I don't know, whatever dimension, sort of, they used to measure it diagonally. What that would tell you in older televisions is that was the dimensions of the glass, but it never took into account the frame that's actually holding the glass in, right? So the frame would usually extend out quite far and cut off the glass, right? So you were never getting a true one-to-one representation of what was shot on film and what was being broadcast on your television. So they came up with this idea of when people go out to shoot movies or television, there's what's called a ground glass put inside the camera to say, look, shoot inside this rectangle. Otherwise, if you have action out here, it might be covered by the frame of the television. And then they have one slightly tighter in for safe title, just to make absolutely sure that anything that's written can be read by an audience. Nowadays, you don't need it because there's a one-to-one relationship between the screen size and what you see. But I generally tend to turn it on because it helps me to, when I select my shot camera, it shows me that I've selected my shot camera and I've got this visual signifier. It also helps me design my compositions a little bit because I don't like really, really tight compositions. I don't like, composing images that are like really super tight along the edge. It gives a very claustrophobic feeling, unless I want to do it deliberately, right? So there we go. I've set that camera up. So now when I flip over to my perspective view and I'm doing my modeling, right, there's no way visually I can confuse it with my shot camera, right? So that's just a little bit of prep for the camera. There's a few other things you can do. You can turn on a field chart. That's what animators generally tend to use when they're trying to map out certain things. But I've used this. I used to use it heavily when I was 2D animating, but I never use it inside a 3D context, right? I'm just gonna frame this up, right? Now, what I'm gonna do in addition to that is I'm gonna go up to my panels again, and we have down here, tear off copy, right? So what this allows you to do is literally tear off a copy of a perspective view and move it to a different viewport, which is kind of cool, right? So I can have this sitting on my second monitor, and you know, I can preview my camera shots. So where this comes in handy is, let's say I want to flip back to my perspective view, right? So here's my perspective view, right? Now I can either come into my camera and sort of manipulate the camera this way, and you can see that it updates the minute I let go. It updates the position of the actual camera. Or I can take the camera here. If I want to physically place it, I can do that, right? And move this around, right? And move it forward. So two different ways of navigating the camera. I can be inside the viewport, or I can physically grab the camera and move it around, right? Now, the camera icon is really super small, right? So there's a few things we can do. I don't know if we can, yeah, you can scale this icon up. But for me personally, I'm always terrified of working with scales because scaling is a multiplier and can oftentimes have unexpected results. I know it's only a sort of non-renderable NURBS curve sort of icon for the camera, but still, there are other ways of increasing the size of that. And if we come down to our display here, we should be able to, I'll explain this in a second. I just want to find where is that again? Is it in the shape node? I'll come back to this and explain exactly what it is that I am, oh, there you go, locator scale. Let me set this first. It's grayed out, so I wonder if they've changed things. Let's see if I can, yeah, I can set it here. That's cool. Okay, no, that's too big. So I'll explain to you exactly what's going on. So now I'm starting to utilize the attribute editor for what it was meant to be used for. Let me close these guys up here, right? So we've got two nodes attached to this camera. The transform node that lets us know exactly where it is in 3D space, and the shape node that describes what that object looks like. The bare minimum nodes that any 3D object has is a shape node and a transform node. That's it. That's consistent across many different 3D packages, right? So I went looking in the wrong place to change the shape of this, right? So in here, right, you can see that there are a lot of things that we can change for the camera, right? We can change the depth of field of the camera. We can change the output settings of the camera. We can change a whole bunch of stuff, right? I generally keep these zipped up until I learn more about them. And as I learn more about one aspect, then I'll unzip it because I'm more familiar with it and then work my way down. This is how I learned Maya back in the day, right? But down here is object display. Literally how this object is being displayed in the viewport, right? So you can see in the object display, I can turn the visibility on and off, right? I can template it if I like. Now you saw the visibility and templating when I showed you the render layers as well, right? So this is just another way of controlling it. We can control the LOD visibility, etc. But we have this locator scale. Now, it's called locator scale because actually what this camera is just a locator object, right? And I'll explain what I don't know if I've explained locators, so I'll explain that in just a second. It's a very, very simple point in space with just a fancy icon attached to it, right? So that locator scale, if I adjust it here, it is only attached to the icon of the camera and it won't be multiplied to anything else. Everywhere else inside of Maya, Maya considers that camera at scale 1. Perfect, right? It's like it's separating that mathematical calculation out so it doesn't get added or multiplied to anything. Whereas, if I'd taken this and just used the scaling here, look, it's adding all this value here, right? See that? That could get multiplied to something else later on. I don't want that. I don't want that. I like this scale factor set to 1 everywhere. So if anything accidentally gets multiplied to it, it won't give me any unpredictable results, right? So I didn't really need to set that, but I wanted to walk you guys through it so I could show you that inside the shape node, you can actually manipulate the shape of the object. And this is one of those areas where you can do exactly that, right? So I'm going to zip that up. That's a good camera size for me at the moment. So there's the camera. Let's talk about the camera shot view and the resolution gate that I highlighted. For this, I'm going to kind of increase the size of this a little bit. So I'm going to open up my render settings, right? So let's open up the render setup. Oh, that's not the hypershade. Come on. It's this one. That's the light editor. No, it's this guy. Render settings. There we go. I stuttered there because they've changed the icons fairly recently, I believe. Okay, so here we are in the render settings, right? So take a look at our camera's resolution gate, right? I can come down here and select that shot 1 camera, and I can say, look, let's go full HD, 1920 by 1080. See how it changes here, 1920 by 1080? So the camera is definitely connected to our renderer, right? So that's sort of really an important consideration. So if we want to adjust specifically what our camera is doing, we need to come into our render settings and make sure that they're set to the appropriate kind of image resolution, right? So again, controlling what the camera will eventually render out is done in the render setting. These two are intrinsically tied together, right? Okay, so as well as when this camera renders out, what is it going to render out, right? So just for the sake of argument, let's just say TIFF. I'll talk about what an EXR is later. Or let's go simpler. You guys are familiar with JPEGs. So we'll render out a JPEG, right? Now you can name it, but where can you tell Maya to go put your rendered images? There's no browse window. You can't really tell Maya where to put those images, right? So that is why I spent an inordinate amount of time walking you through the project window and the set project, because look at this. The path is right here and it is going directly into the project that we set, right into the images folder. Yeah, it's under images and project files. Yeah. I just wanted to make that as a point. And again, to remind you, you are never dealing with single Maya files. You are dealing with the entire directory, right? And so you have to set projects, right? So, and this goes way back to the day when I was first learning XSI, Softimage, right? With Softimage, we had to set up all the database folders manually, right? So all 3D packages like to have all of their folders in a database so that they can connect, textures can connect to objects and so on and so forth. Right, so let's talk about what renderer we're using, right? So if I come actually back up to the render settings, we are using the Arnold renderer, right? Now something I want you guys to understand, the renderer that we use, renderers are generally separate pieces of software. They're completely different programs, right? So you can have your Arnold renderer, you can have your Mental Ray, you can have V-Ray, you can have a whole bunch of different renderers. They can be standalone programs. You can open up a renderer, load up objects, and just render right out of the renderer, right? renderers are generally plugins that Maya can access. So inside the render settings, I'm not rendering out of Maya, I'm rendering out of Arnold. So when I select that renderer, all of these options are manipulating Arnold. If I select a different one, then all of these options change and they're affecting a different renderer, right? Maya comes with a few out of the box. Yeah, like Logic. So Maya comes with a Maya software renderer, hardware renderer, and vector renderer, but they are separate standalone renderers, right? And so if you want, I don't know if you guys have heard of Redshift or Octane. There's a whole bunch of different renderers that you can load in and access inside of Maya, right? So we're using the Arnold renderer, right? So Arnold has a specific way that it processes images for final output, right? But it also has specific, let me minimize that. It also has specific materials, right? I mean, cameras, you don't have to use a renderer-specific camera. Camera's a camera's a camera, right? But let's take a look at this object, and I'm going to right-click and assign a new material. Actually, let's go through the hypershade because it's a little bit more information. So the hypershade controls anything to do with shading, right? So where do we find that? We find that in the rendering editors because it's so closely tied to rendering, right? So in here, we can find the material that we want to put on our object, right? Now, Maya typically has a blend material or a Phong material that shows how the surface is more metallic, and then a Lambert material that's got no reflection, so that would be for jeans or clothing or things like that. But the guys who developed Arnold simply said, well, wait a minute. A material is a material is a material. We just need to switch on the different features that we need. All we need to do is supply people with one material, right? So in that way, the guys that developed Arnold created just an Arnold standard surface material, right? And the standard surface material kind of has all the dials and switches that you can turn on for shading, diffuse, specular. If you want something to be like a Lambert, you can turn off the specular, right? So it's quite logical. You just need to ever apply one material, and then you can fiddle with all of the different dials and switches once you get it inside the hypershade, right? So let's take this guy. I believe it's a middle mouse button drop onto the object. Yeah. So now I've applied that material to the object. I'm going to color it slightly different so we can tell what it is that we're looking at, right? So there's our Arnold material, right? So Arnold material, yeah, it's very similar in Unreal. So if you've worked, well, all of the 3D packages now operate very similarly. So when you're inside Blender or if you're inside Houdini, you will have this node-based sort of approach to texturing, to everything. Texturing, animating, procedural, simulation, anything, right? So if this is looking familiar, it's meant to. I believe the Unreal Engine blueprint system came out first, and people just went, hey, that's a really cool way of organizing node graphs. And so you'll see that this look, that Autodesk will never admit to it, but I think they took it. They lifted it from the way Unreal Engine was doing stuff. In turn, Unreal Engine, those guys took it directly from Houdini. So there you go. Okay, so when I drop that material onto my object, you can see straight away it creates a shading group automatically, right? Because it's automatically assuming, oh, you put that material on that object, you're probably going to want to hook up a few other things as well. So it automatically creates a shading group for you. If I click on that shading group and I want to show incoming connections and outgoing connections, that's what this icon means, input and output connections, and I do that. It's not going to show the geometry in here. I'm going to have to go into something else for that. Let me try a quick experiment. It should show me the incoming. No, okay. So this hypershade now only shows me exactly those nodes that deal with the material properties and the shader properties, right? I was expecting it to operate like the old hypershade, which would also show me geometry connections. But I suppose that's what they're saving this node editor for. Okay, so I've closed out of that just to show you we've got cameras, we've got materials, right? And now we go to lights, right? Oh yeah, I was going to talk about why renderers have specific materials associated with them, or specific material libraries. And it has a lot to do with the way a renderer calculates properties of light across a surface, right? Now, Arnold can support the default Maya materials. Everybody, all renderers can support the default Maya materials because they're simple, they're basic. Everybody has those features in all of their different shaders. But I just get into the habit of using the materials that I know are associated with the renderer because there's less chance of things erroring out, right? Okay, so, Unreal do tend to be trendsetters. I did mention that Unreal may have taken that from Houdini. There's something that you guys may or may not know, is that it's not really corporate espionage, really. It's just that, like when you're in a city like Vancouver, you could tend to work at a variety of different companies. And so oftentimes you just have a group of friends and you just migrate around various different companies and you all think the same and you all have the same philosophy and you just end up applying your work in different places. And it's more of a collective thinking kind of thing, I think. And then you see a lot of innovations start to hit multiple kind of companies, multiple development teams, and everything sort of rises. Yeah, hive mind. Yeah, it is kind of like a hive mind. Actually, I'm not explaining it correctly. I think I'll give you an anecdote instead. When I was in Vancouver, I lived in an apartment right in the central downtown area, and my flatmate, Brian and Addie, we all kind of lived together, and I was working at EA, and Addie was working at Microsoft, and Brian was working at Radical Entertainment at the time. And we're all under NDA, and we're not supposed to be talking to each other about our projects, but I mean, we live together. So that was kind of an interesting situation. But we would share a lot of the stuff that we do. So for example, Addie was working on, he was responsible for modeling the Ferrari Enzo, which became the poster car for Project Gotham. You know, and I was on Need for Speed at the time, and I was like, oh yeah, okay, this is how we're dealing with the cars. So I was working on the, not the Subaru, the Skyline, Nissan Skyline, and we would just trade techniques, right? So not really a hive mind, just kind of like, you just get to know everybody eventually. It is true what they say, the industry is quite small. And that's what they mean when they say that, right? You could end up working at one studio and then a year later working at another studio and so on and so forth. So I'm not surprised that a lot of the best case scenarios or the best practices start to filter around to everybody, right? Okay, yeah, so there's that. So the last thing I want to touch on is the lights. So I'm going to come over here and we can create lights inside here, right? But we can also create... did they move it into the Hypershade? Let me just check this out real quick. I'll bet you they moved it in the Hypershade. Oh yeah, okay. So they moved it in the Hypershade. Let's double click on this. There you go. Oh, actually, I'm just pausing here because I don't want to talk about area lights yet until I introduce the basic lights. Area lights are a little bit more complicated. You know what? I'll just go straight into creating lights. Now, what I was saying before about a renderer working well with a particular material library, same with lights, right? So you want to use Arnold lights. Not as much as possible. Just knowing that if you use an Arnold area light, it's going to not calculate better. It's just developed by the same team that developed the renderer. So you know that they're going to play nice together. That's probably the best way to put it. But Arnold's renderer also recognizes all the very basic lights, right? So I am going to bring in the, let's bring in the directional light. So I'll talk about the directional light. So the directional light is probably the simplest of all the lights, right? Now I'm gonna just quickly scale this up, but we can do the same thing in here. Yeah, actually, let me do it properly. Because when I scale it up, I've got 68.789 multiplier on that light. I don't know if I want that. So I'm going to go over to the directional lights shape node, go down to the object display, and I'm going to change that locator scale to like 50, right? If I come back to the transform node, you can see that it's still all set to 1. So I haven't affected the scale of the light. That's not a huge deal, because what I did with the camera and with the light icon, it's not really going to be effective. But if you get in that habit, when you're modeling, right, where it really matters, you'll have that in the back of your mind that you have to be very, very careful with scaling. Okay, so a directional light, here's how this works. This is sort of transformed into a lighting lecture, but it's all good. Okay, so the directional light is one of the cheapest lights you can have. You can see that I skipped past the ambient light, which is a lot cheaper, and I'll explain why in just a sec. But how are we supposed to know what that light is doing? I'm going to actually come in here, also create a plane, right? So we can see that against the surface, right? And let's take our camera, our shot camera. We'll stash it up here for a sec. And I'll take the render view, minimize that for a second, right? So inside the modeling view, or inside Maya's viewport, default, it just gives a blanket light so that you can see everything, right? And when you're ready to start lighting objects, you have to turn a few things on and off in the viewport. For those of you who are kind of interested, what we're looking at right now is a directional light tied to the camera, right? So it's lighting everything evenly as you rotate around. And it's just the sort of the best lighting condition for when you're modeling, right? But when you're ready to do some lighting, you want to come over here and you want to go to lighting and say, use all lights, or the hotkey number 7, right? So this will make sure that you're using all the lights in the scene. You have a few options as well. You can use selected lights. You can use flat lighting. You can use no lights, etc., right? I'm also going to turn on shadows so we can see that as well, right? Which is why I threw in a ground plane. Now, you'll notice that when I'm rotating around, you'll see some artifacting in the shadow. It's like flickering, right? That's the graphics adapter. Trying desperately to show in real time what those gray lines look like, and the gray lines are really tiny. So you know what? I'm going to turn off the grid, right? So I'm going to come over to my display. I'm going to turn off that grid, right? So here we go. So this way, I can talk to you about what a directional light is. A directional light is just one light beaming infinitely through the scene from everywhere, right? So it's generally used to mimic sunlight, but you notice that when I move it around, it doesn't really have an effect on anything in the scene. I can actually place it anywhere. It's when I rotate the light, it's like I'm rotating the sun, right? So it just has a rotational value. And also, that's why it's really, really cheap to calculate, because there's nothing to calculate. Just one direction, one intensity, right? So let's talk a little bit about that intensity. So if I come over into the attribute editor and I go to the shape tab, you'll see that I've got that directional light and I've got the color of the light, right? So I can change that and set it to whatever I want, right? You know, something like that. And then the intensity, right? And that's it, right? That's all there is to it. It's a very, very simple kind of light. So let me delete that, and we will go back to lighting and use default lighting, right? So we're back to this. Let's bring in the next light, the ambient light. The ambient light has no origin point at all. It just covers everything with this blanket ambient light. And generally, we never use it because the fact that it makes everything muddy. It's like, it's like if you take a 10% gray Photoshop layer and turn the opacity down to 2% and then layer it over everything. It's just going to wash out everything, right? So the ambient light, generally, we never use it. I know there are some lighters. There's one occasion where I used ambient lighting. It was in, I was working on an environment called Nar Shaddaa in Star Wars The Force Unleashed. And Nar Shaddaa was supposed to have like this miasma and of just disgusting smells and noxious fumes sort of lightly coating everything. So in that case, just a really quick kind of cranking up of the ambient sort of worked there a little bit. And I also use the ambient light for the distance buildings. So there's a little bit of washing out the buildings in the distance. So there it kind of worked. But generally I stay away from it, right? Okay, so inside the light, let's go to the point light, right? So let's hit the 7 key, turn on our lights again, and we see nothing, right? So this is good. I'm glad it happened because I used to, run into this a lot with rendering where I'd render something that's like, oh, it's black, it's not worth working, you know? And I think, I can't remember who it was who said, you know what you should do? Just crank your light intensities up super high and see what happens, right? Ooh, and nothing's happening. Am I inside I'm inside an object, right? Right? So if you ever have a situation where you bring a light in and you don't see anything, just these crazy values inside your light will tell you whether or not that light is working, right? And then you can go from there, right? So here we go. We got our light at a value of 1. Now this is the next cheapest light. And what I mean by cheap is that it doesn't take long to process, right? So the point light is the bread and butter lighting, the bread and butter light type for game lighters, right? Because you can put point lights anywhere. And they're really, really quick to calculate, and they won't do anything to your frame rate, really. I mean, obviously, there's a limit to it, right? But they are very, very cheap to calculate, right? So what a point light is light radiating in one direction from the center out 360 degrees. That's basically what a point light is, right? So we can come down here, and if we crank the intensity down to 0.5, you can see we start to fade it out a little bit, and we can bring it in, and you can see that that light is radiating from that. You can sort of see it acting on the surface there, right? Now I brought it in because I want to talk a little bit now about the first sort of attribute that's being introduced for you guys, and that is the decay rate. So this is something we did not have on previous lights, right? So the decay rate is, what does that light do over time and distance? Well, not over time, but over distance, right? So right now it's not doing anything. So it's beaming light from that point going out forever in all directions, right? Now we can actually add a linear decay, and suddenly that light has a range, right? And so we bring back the 1, right? And then we can see that that light falls off over time, and it's got a much more focused sort of center, right? Now this linear decay means that at double the distance, it's half the intensity, right? So it's nice, easy maths. Most lighters, when they're doing their initial pass on lighting, will use linear. Well, maybe not nowadays, but we'll get into that. But back in the day, we used to use linear to set up our initial lighting pass, right? The next one is quadratic. And quadratic has much more of a real world fall off, because light doesn't fall off by half at double the distance. It's more of a logarithmic fall off, right? So quadratic is much more realistic, but to see the effect of it, you really have to crank up the intensity, right? But notice it's got a sharper or a tighter hotspot when you get really, really close. And it's got like a really, really gentle but fast fall off to the light. And then there's cubic, which is even more responsive than that. But then you really have to crank up your values to get that. Now, I'm going to add a layer confusion here, but it's just a theory lecture, right? So with light intensities and fall off, we need to now start thinking about what our camera is doing. Is our camera getting the correct exposure for this? Is the camera receiving the correct light information from this? A transmission fall off? Have we set up our lens characteristics properly, right? So when you're working with real world lights, you also have to go and start balancing real world cameras in addition to that, right? So it starts to get a little bit more complex, right? Okay, so let's see what else we got. We've got our, okay, spotlight I'm gonna move on to. I'll move on to the spotlight and then we'll sort of leave it at that, right? So I'm gonna take this point light, delete it. I'm gonna hit the default lighting and we're back. So any questions about the directional light and the point light? No, it looks like we're good so far. Right. The lighter's favorite tool, the spotlight, right? So I'm gonna bring this guy in. I'm also gonna go back down to the object display and we'll make that locator scale 50 so we can see what's going on. And we'll move this guy out, right? And we'll turn on the use all lights, right? The spotlight, the bread and butter lighting tool, right? So again, all the sort of standard features that you had off the sort of the directional light and the point light, just a couple of other dials and switches to concern yourselves with. So the point light had the color and the intensity and had a decay rate, right? And we'll set this to linear decay. Linear decay is just sort of easier to talk about when introducing lighting, right? So we've got a little bit of a decay. That light's losing energy over the distance that it's traveling, right? But now we have cone angle, right? So the cone angle is easy. It's literally, you know, the size of that spotlight, right? The penumbra angle and the drop off are a little bit different though. So notice we've got that harsh light, right? So the penumbra will soften in from the cone and out from the cone, right? So I don't know what the difference is. Oftentimes I'll set an interior penumbra when I feel like it, or an exterior penumbra. I generally tend to do the exterior penumbra because it gives me positive whole numbers instead of negatives. But, you know, that's just a mild consideration, right? So there, we've got a nice soft kind of cone on that, right? And then we have the drop off, right? Now the drop off, if you can picture the light going in a straight line from the origin out to its destination, the drop off sort of softens evenly across that line, right? So we've got the penumbra being softened, we've got the drop off being softened, and then we've got the decay rate. So all of those kind of work in tandem to give us nice soft lighting, right? Right, so you can see that we're getting, you know, some nice real-time lighting effects, right? There are other lights as well. So we've got the area light and the volume light, but I'm generally save those until later because they're heavily dependent on the renderer, right? So understanding how expensive area lights and volume lights are to work with, you also need to have an understanding of how they impact on your rendering time, right? The murder cube. Yeah, I should have brought a character in here. Would have been more interesting, a little bit more fun. Okay, so the last thing I'm going to talk about are shadows. Actually, I don't want to talk about shadows. Maybe briefly. Okay, so we've got shadows on display here, but let's take a real quick render. Let's pop into our camera shot. Something like that. And I'm going to turn on use all lights so we can see, well, and turn on the shadows in here too, so we can see what's going on. Let me whip that camera around. Let's see what we get from a render from about there, right? So I'm going to go in here and do a quick kind of render view render. Ah, okay. So this is good. It's a good opportunity for me to talk about this. Now, I'm doing a render. I click the render view, and it's rendering at 1920 by 1080, so the full resolution, right? And I see a lot of people make this mistake a lot, quite often, and I've just made that mistake now, rendering at full resolution will take forever, right? So what we generally tend to do is try to set our render view so that we are rendering at a test resolution of like 25%, right? And then we will do a quick render there. I am forgetting something. That's why I've got the render at black. Let's switch over to my alpha. What is it? What is it? I'm forgetting something. I got materials applied. It's an Arnold material. We should be able to get the light. Well, just for the sake of continuing the lighting lecture. Oh, actually, this is a good example too of talking about the dependency of a renderer with materials with the lights, right? So sometimes, well, oftentimes when you first start rendering, you'll run into the black screen quite a bit, right? So what I did there was I really quickly switched to my alpha channel, because the alpha channel shows you if there's something there, right? So you can see, yeah, okay, the alpha channel that the renderer figured out is that there's an object, which is the ground plane, and your cube objects in there somewhere, right? So this tells me, yeah, the renderer is working. It's working. It's my fault that I'm seeing black, right? So this is an old trick. We do it all the time. If your renders are black, turn on the alpha, see if there's something there, and then try and figure out what's going on. In this case, I'm just going to switch to Maya Software and then do another quick render. There we go, right? The Arnold material is a bit glowy, but that's okay, right? But that was a really, really effective demonstration of the fact that your materials and your lights and your camera, they all kind of work together to make a successful render, right? When in doubt, you can switch over to the Maya Software render, and you'll get a pretty decent render. All right, so I'm just going to jack the intensity of this up a little bit and increase the cone angle just a touch. I will take another quick render. Boom. Right. So now we see shadows in the viewport, but we don't see shadows in our renderer, right? Looks like Five Nights at Freddy's. So why we don't see shadows is because we haven't specified in our render settings that we want shadows. Now the reason why no shadows are being rendered by default is because shadows are hella expensive to calculate, right? And so when you choose the type of shadow rendering that you want to turn on, it has to be a very conscious, very thought through decisions. You have two choices when it comes to shadows. You can either do shadow mapped shadows or ray traced shadows, right? So where are my shadow map settings here? Well, let's turn on ray tracing, right? So the two different types of shadows, shadow maps and ray tracing, work this way, right? So if you've got a light, Maya calculates the rays coming from that light, hitting the object, and where they cast that shadow. Then it creates a texture from the point of view of the camera and says, that's what the shadows look like, and it stores it. And when it goes to the next frame to render those shadows, it doesn't calculate those shadows. It renders the objects and then places a shadow map or uses the shadow map texture to calculate what the shadows look like. So it's a lot faster, right? Shadow maps calculate lightning fast because really the shadows were calculated on the first frame and then that's it. Ray tracing is completely different. So ray tracing, every single frame, Maya will shoot rays that simulate the light rays into the scene and bounce them around all over the place, right? So the more rays that you shoot into the scene, the more realistic the lighting. But it calculates all of those rays every single frame, right? So let's turn on ray tracing and we'll take another quick little render, right? Now we've got our shadow, right? Because what the renderer did was it shot a ray from the point of view of the light, hit that cube, calculated where that light ray was going to land, and drew that shadow in real time. Ray traced shadows take longer to calculate than shadow maps, but they are more accurate. That does not mean they are more realistic, though, because there are things that you can do with shadow maps. Shadow maps are a little bit more versatile in terms of creating split shadows, soft shadows, all kinds of different types of shadows that actually, in a lot of ways, can sometimes create more realism than ray traced shadows. But that's for a whole other kind of rendering and shadows lecture, right? So that's it in a nutshell. Super quick, super fast rundown of lights, materials, the object, and what the renderer is doing at a very, very, very basic level, right? So with ray tracing, and this technique is used in a lot of different places, throwing rays into a scene and bouncing them around to create accurate shadows and accurate lighting calculations. How many rays do you think that Maya shoots into a scene to get an accurate measure of what the shadows look like? If you guys don't know, you can hazard a guess. How many rays would you need to beam from this light at the cube to get realistic looking shadows? Yeah, many. Hundreds? Thousands? No, not however big the radius of the cone is, right? Because the radius of the cone dictates another factor, right? 12 is let's start off with 12. That's a good guess. Yeah, 12 is a good guess, right? So you can get reasonably tight shadows with 12. Now let's talk a little bit about, all right, so actually let me grab this. This might be a useful way of explaining it. So let me grab the penumbra and the fall off, and let's set that to 0, and I'll set the drop off to 0, right? So let's say this is 12 sampled rays, and we get a nice tight ring. It's probably going to be more than that because each sampling ray will need to pick up some detail on the surface and then create a pixel from it. So you're probably looking at closer to hundreds. But then if I do this, there's a lot of pixels there that need to be softened. So each pixel has to be calculated a different shade of gray, right? So to kind of give you an idea, generally, if we brought in a few other lighting effects like global illumination and final gathering, I'll talk to you about what those are later. You're probably looking at an average of maybe 20,000 rays scattered around the scene as a first pass lighting. It's probably a little bit higher than that because I'm talking about experiences that are about 5 years old now. So about 20,000 rays. Now, here's a big clue as to why CG things look CG, right? So we got 20,000 rays bouncing around and giving us the shadow detail. Also, with global illumination, we're getting color detail and all kinds of other bounce light detail and all that kind of stuff. We can throw hundreds of thousands of rays into a scene, right? Probably take forever to calculate. So hundreds of thousands of rays. Here's why CG things look CG. Do you know how many rays the human eye can calculate? It's like in the billions. And we process them like in split seconds when we look around, right? But this is why CG stuff still looks CG. And that's why we tend to fake a lot of stuff by layering multiple lighting passes on it, effectively adding more and more nuance to the way things look. The interesting thing about CG, I don't know if you notice, but things look great for about 5 years. New tech comes out, new subtler ways of scanning a scene, and then you look back at the stuff from 5 years ago and it starts to look really fake. So it's kind of interesting. But we are nowhere near photoreal yet, right? I feel that like this lecture sort of blasted through everything really quick. The boundaries of good changes with time. Yes, they do. Our goal is to try to create timeless things, right? It's whatever you are trained to be comfortable with, what you're exposed with. Yeah, absolutely. Yep. So that, brings up the question of the uncanny valley. I don't know if you've heard of the uncanny valley, but there's a lot of people who are saying that people from my generation look at photorealistic CG human beings and go, oh, that doesn't look quite right. Whereas kids who've been born and raised with it, who grew up watching Polar Express, see nothing wrong with it, right? So yeah, very much it's what you're exposed to. Okay, so again, I feel like I blasted through it, but I just wanted to give you a super quick overview. Again, we'll be diving in and kind of pulling the pieces apart and talking a little bit more about that. So what I'm going to do is I'm going to take 5 minutes now. I'll give you guys a 5-minute break. I'm going to go refill my coffee, come back, and I'll talk to you about something different, right? So again, everything I talked about today is not necessarily Maya dependent. You didn't need a running copy of Maya, right? But hopefully you guys can get yourself sorted with a copy of Maya by next week so we can start diving in and doing some practical stuff, right? I still haven't forgotten about the box nor the building facade. So we'll need to revisit that next week, right? Okay, I'm going to take 5. I will be back and we'll pick it up from there. Very cool. Okay. Yeah.
Quick question.
Yeah.
My mother's given Noah £10
Yep.
and he is burning a hole in his pocket. He wants to buy something online.
Yeah.
Is he allowed?
Yeah. Yeah. I just need to supervise him or Connor or you.
Yeah.
Yeah.
There we are, Noah. What do you want to spend it on?
Go on, buddy.
More pet space.
Okay, I'm back. So, hopefully, one sec. Hopefully that wasn't too crazy for you guys. Just a nice gentle introduction to the relationships between everything. Because I want to dive into talking about the relationship with textures. Right? You guys okay with that? How's everybody doing so far? Any questions? Okay, cool. Now, what I've just taught you is universal across many 3D platforms, right? So 3D Studio Max, XSI, Cinema 4D, all of it. It's the bread and butter basics. All 3D packages can do that, including what I'm going to talk about in terms of texturing, right? So now we've just got this cube, right? And it's lit and it's beautifully shot. Look at that dramatic cinematic camera. Whoa, cool. So we need to turn it into something, right? I'm kicking myself for doing this, but it's going to be the dice lecture. I hated the dice lecture when I was in your place, but there's no other better way to explain it, right? So what I'm going to do is I'm going to texture this and try to explain to you the three main types of texture map and how they work together to build your shader, right? So first of all, just as a quick reminder, we're gonna pop into the Windows rendering editors, Hypershade, right? Which I'm still not 100% comfortable with using this Hypershade as of yet, but we'll get there, right? So we've got our surface shader and it's attached to our shading group. So the surface shader, we've got all of these different sort of things that control how that surface looks. The base, the diffuse roughness, the metalness, the specular, etc., etc., etc. What I'll actually probably do, because we had to switch to the Maya software render, I'm going to delete this material, right? And we'll assign a new material to our object, right? Just because it'll be easier to kind of talk about in context with the attribute editor, right? So I'm just using a blend. Because we're using Maya software, all the Maya materials will render fine. Okay, so we've got same thing as we saw in the Hypershade. We've got the color, transparency. In fact, if I were to open up the Hypershade again, it's identical, right? Let's pop over into our Hypershade, right? There's our blend. See why I switched materials? There's quite a lot less to play with, but it makes it easier to digest a few of the concepts I'm about to throw at you, right? So all of these different sort of categories are identical. Color, transparency, ambient. Color, ambient, transparency is down here, right? And so now we're going to plug textures into these various areas, right? So we want to create a dice, right? So I'm going to come up over here and we'll find a good dice texture, right? So I'm going to probably look for old dice. Yeah, cool. Something like this. It'll be a little bit more visually interesting to work with, right? So, I'm just going to take a quick scan and see if we can find something a little bit better. Let's go to make sure we get only the large size ones. Actually, this is kind of cool. Okay, so I'm going to open that image in a new tab. And I'm going 2. Save this image as, right? So I'm going to put this, oh, actually, let's come back here and save scene as. So I'll make sure we're in the right projects. Oh, come on. Okay, so we're in the projection modeling project. That's all right. So I'll make this P002 prop 2 and die 1. Save that as a Maya ASCII. And I'm going to come back to where I've got this texture and save image as. And we will save this. It was in here, wasn't it? I think so. And in projects, lectures, projection modeling, and images, and raw. So I'm going to save that in there, right? So now we can't apply this texture directly to the object, can we? Well, let's try it. So I'm going to come over to the color, open up the checkerboard swatch, grab that file texture, right? So I've created a file node. Let me show you by opening up, again, the rendering editor is the Hypershade, right? I come back in here, and if we were to show incoming, outcoming connections, check it out. I just created that, right? So by clicking on the color node, I created a file texture node, right? That's this thing here, and it's plugged into the color channel. So I want to name that T underscore for texture and die 1, right? And now I'm going to put the addition of color, because it's my color map, right? So I'm going to navigate to that using the browse window. And once again, I put it in the wrong folder. That's all right. So I'm going to grab that dice and I'm going to apply that, right? I move this, actually, I'll just minimize the Hypershade. Now, we can't see it in the window, right? Because remember, Maya's viewport shows you the bare minimum so that you can operate inside of a real-time context and it's not going to bog out on you with loads of latency. So let's turn on our textures. So again, it's up here in these menu items that deal with your viewport. I'm going to go to shading and I'm going to turn on hardware texturing. Boom. Yeah, it doesn't quite work, does it? Right? So let's see what's happening. Now remember, if we take a look, and I know this is repeating myself, but I like to repeat this because texturing and UVing is oftentimes a very difficult concept to understand. This 3D cube is not actually 3D, right? It is a flat 2D image of a 3D dice that we've just wrapped around our object, right? So that's what we're looking at here, and it's not going to work for us, right? So if we want to take a look at how that UV texture is wrapping around our object, we need to take a look at our UV editor, right? So when I come over up to Windows and I go to General Editors, I can open up my, oh yeah, they moved it, didn't they? Where did they move it to? Modeling Editor, UV Editor. Okay. So if we take a look at this particular object, right? Inside the UV editor, what the UV editor shows us is the wrapping paper, right? What it looks like, that flat wrapping paper, right? And this UV shell is our object, right? So what we need to do is we need to make sure we can align the texture with the object. So basically what the UV texture editor has done has taken this box, unfolded it, laid it flat to make it easier for us to put the wrapping paper on top of it, and then it'll refold up that box, and then hopefully things are perfect, right? So that's kind of what the UV texture editor is doing, right? What I like to do is I like to, not that one, dim down the texture, right? So we can see the UV shell a little bit better. We need to do some work on the texture itself, right? So here's what we need to do. So I'm gonna pop into where my project is. And we are going to edit this, right? So I'm going to pop over to the documents and projects, lectures, projection modeling, and it's in images and in raw. And there's our dice image. So I'm going to right click and I'm going to open this in Adobe Photoshop. I'm going to talk about a few technical things that you have to be aware of when you're texturing inside of any 3D package. Let me open this up first. Okay, so with that, I'm going to, where's my open with? Open with, right? And Photoshop. So first of all, this texture is not a square. Because of one of the idiosyncratic ways that texture projections work in any kind of 3D package, the best way to texture an object is to make sure that you are using a square. It makes for nice, clean mathematics when wrapping that texture around a 3D object. Not saying that you can't use irregular shaped textures. You can, but you sort of have to wrap your brain around it a little bit. And there's a few things that you got to do to prep textures. It's just not worth it. It's not worth the hassle. It's a lot easier to just make a square canvas and then stick your textures on there, right? So you can see that because this texture is not a square, right? It's actually squished because Maya's taking a rectangular texture and forcing it to be a square. But then we have image distortion in our cube, and that's not good. So Photoshop's opening up here. Now, I know there are other ways of texturing an object. There's Substance Designer, Substance Painter, there's Mari, we'll get into that. This is the basic bread and butter of texturing, and it gives us an idea. Well, it gives me an opportunity to explain to you certain very crucial concepts, right? What are you still thinking about? There we go. Okay, so I'm going to move this over, right? The first thing I want to do is I want to square this up. Now, it's giving me the crop tools, but I generally just come over to my image canvas size. Now, the canvas size is the canvas, not the image. That's an important consideration, right? So I'm going to say, look, you've got a width of 2000 and a height of 1333. I think if I just say keep that in the middle and adjust this to 1333, we'll probably still miss the object. It says I'm going to reduce the canvas size. Some clipping will occur on the image. Yeah, I think we'll miss the dot. Yeah, so we're still okay. So now we have a nice square texture, right? I'm going to turn off the gubbins that Photoshop turns on for you. So that's going to map a little bit nicer, right? So straight away, I'm going to save this as. And in my images folder, I'm going to save this. Let's just work with JPEG for the time being, right? So I'm going to call this T_die1_color, right? So that's my color map, right? There we go. And I'm going to say keep the maximum quality, right? Now we need to turn this into a flat square. So how are we going to do that? Well, here's what I'm going to do. I'm going to bring over my Photoshop tools from here, and I'm going to go into my polygonal lasso tool, right? And I'm going to just really quickly, let's go in here. Oh. Well, good enough. So I'm going to right click on here and say layer via copy. I'm going to keep the original. I'm going to Control J this, turn that off, and then for the background, I will just fill it. Oops. I will fill it so it's nice and dark, right? So what we're about to do is undistort a texture, right? And this is one of those things that you do all the time as a CG artist, right? So I'm going to come in here and I'm going to free transform this. Maybe we'll start off with a skew. something like that. And rotate this guy around. So I want to make sure I'm going to turn on my view and my rulers. And here, yeah, what's up, buddy?
I'm buying half, so do you mind if I buy the Among Us Pets right now?
Yeah, you can. Yeah, have Connor walk you through it, right? Okay, whoops. You. Okay, so rotated that over. I'm going to go to the side of the ruler, left click, pull a ruler over this way, and pull a ruler over this way, right? That's all I'm doing. Just, I might, let's skew or distort. You know, whatever you want to use, right? Oh. So you guys get the idea anyway, right? And then we can just that kind of a thing. Now, I'm not going to spend a whole heap of time on this. Just want to get this reasonably close. Yeah, something like that, right? Now we got to. I'm gonna come over to view, and I'm going to clear the guides that I pulled out from the rulers, so they're gone. And now I'm just going to, whoops, just kind of eyeball it back to a square. Now there are a couple of issues that I need to sort of address in terms of undistorting textures. Now I picked that particular dice picture for a reason. Right? If we take a look at that original, right? And we take a look at our undistorted, whoops, right? Our undistorted kind of image, right? If we come in, right? Notice we've got better detail, actually up here, better detail here, and then out here it gets blurry. You guys see that? This is a horrible picture to use to undistort, because it's got a little bit of that depth of field and there's not enough pixel information back there to give us a good image, right? So therefore, if you are going to undistort textures from an object, camera's macro on the object, you'll notice one side has more detail. Yeah, absolutely. Yep. If you want better textures, it's best to take your own texture photos so you can be completely orthogonal to the surfaces that you need. And that when you go to undistort them, you're not doing these radical undistortions, right? But that's okay. Just wanted to show you what happens when you do that. Now, I'm not going to undistort the other sides. I'm going to just Control J, right? And Control T, and we'll just flip horizontal, and we've got our other side, right? And we got a little bit of sort of artifacting going on. So, well, not artifacting, but a little bit of extraneous detail. I'll just come in here. I'm not doing a super neat job on this. Just want to show you sort of the result of it, right? So let's say we got something like that. I'm going to grab these guys. Move them over, right? And I might grab this guy, Control J, Control T. I'm going to flip this horizontal again, move this over here, something like that, you know? Right. Let's just leave it at that. It's enough that you guys will get the idea, right? Yeah, no, yeah, we'll leave it at that. Yeah. Okay, so I'm going to take this, move this down, right? And then I'm going to Control Shift S to save this off. It'll default to the Photoshop file, but let's cook out a JPEG, right? So I'm going to create this as a JPEG. I'm going to overwrite the original, right? And say, yeah, let's replace that. That is our JPEG image, right? So I'm literally kind of unwrapping this texture so that we can, again, use it here. So inside here, again, this is the UV editor. I'll minimize that just so we can see what's going on. So let's grab this object again. I'll move the UV toolkit out of the way, right? We got our blend material there. I should name this. Right? So M for material underscore dye 1, right? And then we'll go to the color channel and we'll navigate to the color map. And all we have to do is click on the folder and just say, you know what? Let's switch you from the raw image to the one that I unwrapped. Boom. So there it goes. Now it's on the object. We can see it a little bit better. So let's take a look at our UV texture editor. So I'm going to go into my Windows, modeling editor, whoops, not that one. Windows, modeling editor, UV editor, right? And we'll select the object. So now we can see what's happening with the object on the box, right? Now I'm going to take actually our spotlight and angle it a little bit because we've got it shading somewhat on one side. So let's try and get this kind of sorted out, right? So I talked to you guys a little bit about UV unwrapping, so I'm not going to spend a lot of time on it. I'm going to move these 3 squares up and match them up with the texture so that when that wrapping paper kind of wraps around it, it's nice and even, right? So to do this, I'm going to right click inside the UV editor and select UVs. And I'm going to select those UVs down there. You can tell I've got them because you can see that they look like vertices, but they're not. They're UV points are references to vertex locations, but you can move them around, right? It's kind of like, the best metaphor is, if you've got an object that has vertices, your UVs are like a piece of saran wrap or cling film over top that object with marker dots on them, right? So you can slide that cling film all over the place. That's what you're doing with the UVs. You'll see. So I'm not even altering this object. I'm just taking that UV shell and I'm moving it up, right? So you can see I'm sliding it over the surface of that object, right? And I'm just going to uniformly scale this up, right? And then I just sort of eyeballed the texture, so it's not going to be perfect. But there you go. We're just kind of lining it up with our texture page. And there we go, right? So there is our object with our color map on it, right? Okay, cool. So I'm going to minimize that. And let's find a good kind of angle. And let's do a quick little render and see what we get. So that's it. That's what our cube is looking like currently, but it doesn't look very realistic, right? I don't think I'm rendering the correct camera as well. So let's, where are we here? Yeah, I'm rendering on the perspective camera. So I'm going to go back into my render settings. Don't worry about this. I'm just sort of doing this super quick. Let's make this non-renderable. Oh, turn off the alpha mask. Yeah, so that's selected. So when I hit this, we should render out of the shot camera. Why are we rendering out of that one? Oh, here we go. Shot camera. Thank you. Okay, so here's our shot camera and the render, right? So let's talk about how we can improve this, right? So I'm going to zoom up so we can see a little bit more of the detailing, right? And then we'll take another quick render. Looks very flat, right? Because again, it's just sort of wrapping paper that's kind of wrapped around the object. So we want to get the grooves in the object, right? So what we're going to do is we're going to create something called a bump map, right? In fact, we got 15 minutes left. I think the bump map is the only thing I might be able to introduce you to, because I got to talk about the theory behind the bump map, right? So what I'm going to do is I'm going to hit Control J and duplicate my color map. So this one will be my color. And I'm going to make something called a bump map. Have you guys heard of bump maps before? I reckon some of you have. No? Okay, cool. So for the sake of just lecturing, I'm just going to create a new layer. Oh yeah, a couple people have heard of bump maps. Okay. So a little bit of background on bump maps, right? So when you're modeling stuff like this, that's got bumps, right? And light hits it, the renderer calculates how that light bounces off, right? It hits it and it bounces off a particular way. And that gives it its up and down. And it knows when things are in cavity because of the way light bounces off of it, and it shades it dark, right? So there was a scientist named Bui-Tong Phong, a Vietnamese scientist, who took a step back and said, you know what? Let's look at these bounces, because that's really the information that the renderer needs to figure out where the light and shadow is, right? So what he did was he just took a flat image, right? And with a flat image, when you bounce, you guys remember your index of refraction or your index of reflection or what have you. You know, if something comes in at an acute angle and hits a flat surface, the equal angle happens to a perpendicular 90 degree to that flat surface. The equivalent angle happens on the bounce, right? That kind of thing. So what Phong noticed is that if that light ray hit a surface or hit a particular vertex, if that vertex had certain information ahead of time, you can dictate which way that's going to bounce, right? So if it came in this way, you can have it bounce like this, right? Or you can tell it to bounce that way, right? And so the information he wanted to give the light rays was in the form of a black and white map. So we noticed that when he colored certain areas black and certain areas white, he can control how that light bent, right? So if we take a look at, let's take a look at, a faceted sphere, right? So we can see that in a faceted sphere, right? The light's bouncing off the surface, but it's changing direction harshly, right? So then you get that sort of hard edge, right? Let's see. What would be a good... oh, here we go. Here's a good... Okay. So what Phong realized by being able to bend the light, a couple of different things. First of all, you could take an object that looked like this, that had this geometry, right? And the light would bounce off the surface, but every time it hit an edge, it would change directions, and so you get that hard edge separating the quads. He cheated it by saying, look, if light goes this way and bounces off, light goes this way, bounces off, and we get the hard edge there, right? If we could trick the light so that when it hit that edge, it bounced smoothly across that surface, what you would get is something that had a smooth transition, right? So if I were to come in here and let's open this image in a new tab, right? And that way I can zoom in a little bit. If you look at the edge, it's still got the facets, right? But you have to look closely for it. Across the surface, it looks like a smooth rubber ball, right? Because Phong knew that if you bent that reflected ray a particular way, you could create this smooth sort of shading, right? And again, he took that one step further and said you could actually create bumps and valleys, shadowed areas, etc., just by manipulating how that light ray bounced. So he used black and white values in a texture to say, okay, have the light bounce a particular way or not, right? I don't know if that makes sense. I have explained this before in years past. I don't know if I'm explaining it very well. So what we're going to do is we're going to take this and I'm going to go to Image Adjust, Hue and Saturation, right? The first thing I'm going to do, it's a little bit of a cheat, but I'm going to turn that saturation down. I'm going to turn the lightness down, but I'm also going to image adjust. I'm going to muck about with the contrast a little bit. Higher contrast, make that a bit brighter, right? I'll also, for the sake of demonstration, I'm going to just grab a brush and switch to black, and then I'll just write my name on here, right? So now we've created a black and white map, right? And this black and white map is not actually coloring our object. It's telling the light that hits the object how to behave, right? And I'm using the original because I know that these grooves are going to be cut in, so they won't bounce a lot of light, right? So let me save this off. And again, we'll set this as a JPEG. And this time, I'm going to call this one bump. So now we have two textures. We have a color texture and we have a bump map texture, right? So here's how this works. I'm going to minimize this. I'm going to come back to our object. We'll leave the camera shot the way it is. I'm going to highlight the object, and we're going to go into the attribute editor. And this time, I'm going to go into the bump mapping channel. We've got transparency, ambient, incandescent. We don't need those for the time being. We'll skip those. We'll go right into the bump map. And I'm going to click on the file texture node, and that's plugged in. And you can see now we have two nodes attached to our object. I'll show you by going back into the Windows, rendering editors, Hypershade. Let's take a look at this, right? So, man, our shader is being built as we speak. Here's that material we gave it. Here's the color texture. Notice how the naming convention comes in handy. I can tell straight away that this is the color map, and it's going into the color channel. We have our bump map, which I haven't named yet. I'm going to do that now. Come over here, color T underscore die 1 underscore bump, right? So now this is our bump map, right? And these are the UV coordinates that are attached to those maps, except this has an extra node. This node is responsible for controlling how high or how low that bump value is going to look, right? And we can't control the bump value because we're saying, look, we don't have to control the bump value. We have a black and white texture controlling the bump value, telling that object when to be dark, when to be light, right? So that's plugged in. We've got that bump map in there. Now let's take a render and see what we get, right? So for comparison's sake, what I'm going to do is, where is the, it's this one, isn't it? Yeah. I'm going to keep that image and we'll take another render. Oh, there's a minor difference. Let me see if I can. Let's pop back up here and actually, let's see if we can adjust this by cranking up that bump depth. Let's see what we get here. Oh, it's not creating as dramatic an effect as I was hoping. Let's see. Let's try and zoom in a little bit here. Okay, I'm going to keep this image and come back and disconnect the bump map. Well, actually, before I do that, I think yeah, JPEG doesn't support alpha. I'm not making an alpha map, right? Yeah, let's try the 100. Or are you telling me Maya's reading Just the alpha channel for bump maps now? That shouldn't be the case. Big image and had the negative space. Would it affect it? No, it doesn't affect it. Because the UV coordinates are just attached to that image in and of itself. Use as a bump map. Let's see if we can really crank this up. We get some artifacting, actually, when we move back and forth, but we're not getting the right bump map value. Okay, so let's try and bring up that contrast. Okay, let's try that. Yeah, I'm bumping up the contrast just to, I mean, I've had contrast that was a little bit less than that, so it's a bit strange. Just wondering why it's not reading that bump. Okay, pop in here. We got the bump map, and you know what? Perhaps it would help if I had the image plugged in, wouldn't it, guys? There you go. All right, let's go turn some values down. Ah, Christ. It's one of those days. All right. So I'm going to pop back up over here, and we'll go to our Windows, Rendering Editors, Hypershade. And there we go, right? So we see a little thumbnail here showing that I have that image plugged in. That ought to do it. Okay, so let's bring that bump value back down to 1. Otherwise, we're going to have to deal with some craziness. Let me save this image, render. There we go, right? That's what I'm after. Yeah, it helps if I plug the texture in, doesn't it? Okay, so, and you guys live in those lucky days where you'll have real-time preview of bump maps. I was in the day where you would never be able to see your bump map until you take a render. Okay, so let's talk a little bit about what the bump map is doing. Now, the bump map looks a little odd, doesn't it? It's a bit strange, right? So we have to fine-tune this a little bit, first of all. So I'm going to head on into not the place 2D texture node. Let's go a little bit further in. Pop over here back into our Hypershade again. And let's grab that bump 2D node. Let's take it down to half, and then we'll talk a little bit about it. Oh, I'm gonna stash that image and take another quick render. That's a little bit better, right? So you can see on the side here what it's doing. It's giving us that sense that that has been cut into the surface, right? But if we get really, really close to that object, oh, actually, I should be doing it in the camera shot, right? If we come super close and we try to take a render of that, that looks like it's actually been gouged out of the surface, right? But when you look here, you can tell that it's a flat polygon. It's not actually cut into the surface at all because it's just an illusion. That black and white texture map is telling how the light rays how to bounce. And so we'll get that sense that the light is not bouncing correctly in there. It's maybe trapped in there or bouncing at weird angles. And then so it's darker, right? So there are problems with this type of mapping. And I'll tell you what the problem is, right? And why it looks a little bit strange. The bump map, when it was first developed, could only calculate height information, right? So even though I drew that Photoshop drawing of, oh, I deleted that layer. Let's bring in another layer, right? So even though I came here and drew this, right? Really, Fong's research work could only tell the light how high to go or how low to go in one direction, right? And therefore, you'll oftentimes hear bump maps referred to as height maps. That's all it is, up and down, right? So that's why we get this weird sort of what's called the bump map look, where you can see the kind of cracks and crevices, but there's something kind of plasticky looking about. I don't know, it just looks really, really strange because the light is not bending at all angles. And that was a limitation of the bump map. It was only a black and white value, up or down, right? And we all know that light bounces in multiple different directions, right? So to sort of help with that situation, the normal map was developed. Have you guys heard of normal maps? Yeah, normal maps are red, green, and blue maps. But the red, green, and blue store X, Y, and Z information. So what that means is that you'll get a little bit nicer looking detail because the light is being bounced in 3 axes. So it's got more realistic bounces. Therefore, the normal map looks 1,000 times better than a bump map, right? So a bump map is black and white, up or down. And the normal map is RGB, or X, Y, and Z light bounces. Now, I'm not going to get into normal maps just yet because I want to walk you through how to create a normal map, how they work, and et cetera, and that's for a later sort of lecture. But this is just about giving you guys the idea of where those maps you may have heard of, where they came from, right? So anybody who's a game fan or game fanatic have heard of normal maps and maybe weren't really sure what that was or what that meant. Well, that's what it is. It's using texture information to control light and fake detail. That's pretty much what it's doing, right? So actually, I do have a bit of time. The last map I'll introduce you to will be the specular map. And for this, I might, what's the best way to, let's see if we can, there you go. All right, so I'm going to save this off. As a specular map. And I'll talk to you about what a specular map is. And this time I'll remember to plug it in. So here I'm going to call this specular, right? And we'll save that off. Now the bump map is good for, can you make normal maps in Photoshop? Yes, we used to hand paint stuff in Photoshop. We used to have to hand paint out artifacts generated by normal maps, but it's never as good. It ended up creating smeary looking normal map detail. It's hard to explain. So any and every character artist on the planet, myself included, couldn't wait until we could paint on our 3D models. And you guys are lucky enough that you're in the generation where you no longer need to paint normal maps in Photoshop anymore. You can do normal map, you can create normal maps in any kind of 3D package directly on your character model. I'll tell you, one of the things that we used to do, we wanted to paint normal maps so badly on our characters. We cook out our normal maps, and then what I'd do is I would plug them into the color channel, remap them onto my Maya character, and then hand paint those changes there. Those normal maps would also be saved into a location, which would automatically jump back into the normal channel so I can see the changes there live on the fly, right? I did learn how to generate a rock normal map in Photoshop, but I'm not sure whether that's how people do it normally. Oh, I'm talking specifically about characters. There are some environment artists who like to create normal maps inside Photoshop. Or actually, here's the best example. If I were to do a metal door with widgets and with bolts and kind of grooves and grilling cut into it, I might do that in Photoshop. because that door is a flat prop anyway, and I can get nice mathematical shapes inside of Photoshop, and I might paint a normal map that way. But to be honest, I would still rather paint on the 3D object, because then you can see the 3D object sort of come to life as you're painting your normal map, and it's way cooler, right? But it's good to have that skill and to understand how Photoshop works in terms of creating these types of texture maps. So the last map I'm introducing you to is called a specular map. Unfortunately, I realize right now by picking a wooden die, there's no specular color. So you're just gonna have to bear with me, right? So the third most important map is the specular map. And what that does is it controls reflection off your object, light reflecting off your object. So I'm gonna come over here now to my specular color and do the same thing. I'm gonna click on that swatch, grab a file node. I'm gonna name that file node T underscore die01 underscore specular, right? And I'm gonna this time remember to plug my map in, which is this guy here, right? So I'm gonna save this and re-render. Oops. Let's save that one. And come back here. It's going to break the connection to the specular color for a quick sec. Can actually take another render, right? So that we can scrub back and forth, and it's like there's a slight lighting change. It's not massive. I wonder if I can do something that's a little bit more dramatic here. Let me something like that. We'll go to JPEG, add specular, save. Yeah, save that in. And we'll go back, we'll connect this guy up again. T underscore die1 specular. And we'll navigate to the map and connect that up. Plug that in. Save, and then take another render. Let's see if we can make some adjustment. It's really, it's there, but it's really super subtle. No, I want the specular node. So we'll go to Windows, Rendering Editors, Hypershade. I will grab that. Kill that one. Grab that specular node and come down and increase the reflectivity. Let's see if that makes a difference. If not, I'll just explain to you what it does. Yeah, it might be that the surface is too even and it's not picking up the, oh, it is picking up the scratch work down here in the corner. Let me change this camera a little bit. So we're up like this a bit more. It's always tough to kind of detect the specular anyway. So what the specular does is adds those light reflections, right, to an object, right? So you can add scratches, like metal scratches to metal doors and things like that, peeling paint. And so as the light travels across the surface, the light will catch those little glints of specularity off that. And again, that's also controlled by a texture map. So the texture map, where there are areas that are black, it's telling the rendering engine there's no reflection there. It's just a matte surface. Where it's white, it's going to reflect light back at you, right? Now, a specular map is a massive cheat because it's not a true reflection, right? So whereas an actual metal object that's scratched up looks like it's reflecting white, it's not. It's actually reflecting your reflection back at you. There's some color values and stuff like that inside that light bounce. But a specular map is just pure white. Right? But it's good enough. It works in a lot of cases. Looks fantastic. And in a lot of cases, when you're looking at really tiny hairline scratches on an object, you don't need to see anything other than white light being reflected back. Or you can control the color as well, right? So if you look at the specular channel, you can control what that specular color is, right? So here's the reflected color. You set that, and whatever you set, so you can have the specularity hit you back with light blue, right? Or something of that nature, right? So those are the three texture maps you generally create when creating an object or a character, right? So you've got your color map, your bump map to describe how bumpy that surface is, and your specular map if you want to describe how parts of that object are reflecting light back at the world, right? So that's it. And that's also the bare minimum of maps you would apply to a 3D object, right? Now, you can see that you can take that texture map and you can go crazy with it. So if we take a look at this blend material shader, I can create a texture map that controls transparency. Actually, let's try that just for fun, right? So I'm going to come in here. Also, the transparency map is also a black and white map, right? But I think areas that are white are opaque. Areas that are black are transparent. And it's just passing that information on to the renderer, right? So I can go die 1, right? And then I'll navigate. I'll reuse the specular map. Let's reuse the bump map. It's a little harsher, right? Oh, actually, you can see it straight away in the viewport. Check it out, right? So that texture map is controlling the way light operates on that object in the transparency channel, right? So if I save that, right, render it out. Well, actually, I don't know if you'd see. You see a bit of it, I think, right in through there. Let's see. So if I scrub back and forth, yeah, there's a bit of, you can see it. You can see the other side of that cube right through there, right? It's more dramatic inside the viewport, right? So every channel inside an object's material, from its color to its transparency to its incandescence, can be controlled by a texture map. Once you've UV unwrapped the object, the power to be able to customize that object to what you want is just incredible because it's all controlled by hand-painted textures. I mean, let's just for fun, real quickly, pop into the incandescence channel and I will grab that. Let's grab the specular here instead, open that up, right? So you can see that the object fades out a little bit, right? Because the incandescent map is controlling how that object emits light, right? So now it's bright, it's emitting light, right? So all that stuff can be controlled by a texture, right? So that's it. That's all I wanted to cover, like super quickly, light touch. Everything from how the material, the relationship between the materials, cameras, lights affect the renderer, to how when you get into a material to build a shader, how you build the shader with these custom texture maps. Now, I reuse the same texture over and over again. You don't necessarily need to. You can do some very, very creative things, like writing my name or scratching it, or you can paint something completely different. And mix and matching those different textures can come up with some really, really interesting results, right? So we'll take this one step further and we'll revisit the projection mapping and the box modeling, and we'll start playing with textures, right? So hopefully by next class, you guys will all have a working copy of Maya installed and ready to go, and then we can take it from there. Okay, that's me done in a nutshell. Are there any questions about any of this that we've covered today? Today felt long. Yeah, I know. I apologize because there's a lot of technical stuff to cover, and it's also at a very basic level. So some of you who've done 3D stuff before might have found this a bit Yawnsville. Yeah. So for those of you, I'm also trying to balance my lectures so that I'm also hitting those of you who never used a piece of 3D software before. So I'm really struggling to try to kind of explain in the simplest terms, in easily digestible chunks, of how everything kind of works in a 3D context, right? So don't worry about it. The basics, again, the basics that I've run you through are applicable to any 3D package, right? As well, they are the bread and butter of how we're going to start putting models together, right? The one thing that you will find when we start talking about Substance Painter is the fact that you can paint all 3 maps at once. So that might be hard to wrap your head around, but you'll understand once we get into Substance Painter. Yeah, navigating around in the user interface is going to be a big thing to get used to. Yeah, the relationship between the different texture maps is sort of difficult to wrap your head around at first, but once you start playing with mixing and matching various different effects, it's like a whole hell of a lot of fun. Okay, thanks, Julia. I'm glad that it's easy to follow. I feel like I was a bit scrambled today talking to you guys. It's because earlier I was trying to, I don't know if you've seen my stream, some of the earlier broadcasts from today. I was really struggling to figure out why I was losing bandwidth. But that's all good. Again, before I let you guys go, as per usual, if you have any questions that you forgot to ask or didn't think of until much later, just drop them in the Discord. Right? Okay, cool. I'm going to let you go. I hear my wife downstairs saying grubs up, and I'm starving. I don't know about you guys. So it's time to go chow down. All right, I'll talk to you guys later. Cheers. And that's it for that. There are lots of other basic tutorials that deal with how all of that stuff works. To be honest, I sort of made it up on the fly with the cube. My original intention was to dive in to a projection mapping technique where we're building a building facade, and I could kind of walk through the various different effects, including the window transparency of the buildings and all that kind of stuff. But finding out that people didn't have Maya fully downloaded or installed threw kind of a wrench in the works. So I wanted to do a theory-based kind of talk about the very basic principles by using an object that was very, very simple and easy to kind of understand the concepts. I think that everybody will understand it a little bit deeper once we start building objects together, assets together inside of Maya. It'll start to make a little bit more sense. So there you go. I will talk to you guys later. Thanks for tuning in. And again, with you guys.